Today we're going to be talking about graphing lines from standard form. Standard form is the way that you'd be more likely to see a problem in a real-world scenario, so it is important that we do understand how to graph from here. Standard form usually looks something like this. AX plus BY is equal to C, which is some number. A, B, and C are just some number. You'll notice that in slope-intercept form, what we're used to seeing, y is solved for, but in standard form, what is solved for? What would be C, whatever number is there. That's kind of how you can identify them pretty quickly. Now, when it comes to standard form, there are two basic ways to do these problems. The first is the more formal way, and the second one is the way that I kind of expect that you would end up doing it on an assessment. You are welcome to do it either way, whichever way makes more sense to you. So let's first talk about the more formal way. The more formal way is to find the x and y intercepts. Meaning, what you would do is to find the x or y intercept, you plug in 0 for x and then 0 for y and find the points that correspond with that. So let's go ahead and do that. We'll start with the x intercept. We'll go ahead and use this equation here. 2x minus 3y is equal to 12. We want to figure out what happens when x is equal to 0. So let's go ahead. We're going to get rid of our x. We're going to plug in 0 there. Now, anything multiplied by 0 becomes 0. So essentially, this part of it kind of goes away, leaving us with negative 3y is equal to 12, or y is equal to negative 4 if we divide by negative 3 to both sides. If I were to write that as an ordered pair, we would get 0 for x, negative 4 for y. We could go over to our graph over here and plot our points. 0, down 1, 2, 3, 4 to find our y-intercept. Let's go ahead and repeat this process, but instead of plugging in 0 for x, we're going to plug it in for y. So I'm just going to go ahead and rewrite my equation. I'll do it in a different color to help differentiate. We're going to have 2x minus 3y is equal to 12. I'm going to go ahead and get rid of our y, and we're going to replace that with 0. Anything multiplied by 0 kind of goes away, giving us 2x plus 0 is equal to 12. Divide each side by 2. That will give us x is equal to 6. So when y is 0, x is 6. Sorry, you might be able to hear my cat in the background. She's just making her presence known today. I'm filming these at home. So if we were to write that as an ordered pair, we would have 6, 0. From here, we can simply graph our points. 1, 2, 3, 4, 5, 6, 0. And from there, we can connect our two dots with this line. Close enough for government work. You get the idea. And there is our equation. The other way that you could go about solving these problems, oops, I forgot a little parenthesis there, is to solve for y. We can take a standard form equation and turn it into slope-intercept form by solving for y. Get the y by itself. Now, what's keeping the y from being by itself? Well, we have the negative 3 and the 2x. So let's go ahead and get rid of the 2x first. I'm going to do my work in blue. We subtract 2x from both sides. giving us negative 3y is equal to 12 minus 2x. Divide by negative 3. And we will suddenly have y is equal to 2/3 x minus 4. I switched that around. I probably skipped a step. So I'm going to go back and try again. Y equals negative 4 minus 2 over negative 3x. Keep in mind, if you have a negative divided by a negative, if we wanted to simplify that, that would become positive 2/3. And then I'm going to go ahead and switch this around so it's closer to what we think of as slope-intercept form. Y equals 2/3 x minus 4. This follows what we expect slope-intercept form to look like. Y equals mx plus b, where m is our slope and b is our y-intercept. So, to graph this line, we could simply first find our y-intercept, which in this case is negative 4. Oh, that matches what we did above. That's a good sign. And then from here, we can use our slope to find our next point. Remember, slope is rise over run, meaning we've got to go up to, I'm going to do this in a different color just to differentiate, up to, run 3 in a positive direction because we have a positive slope. We could repeat the process to get our 3 points. Oh, look, that's the same x-intercept that we had above. From here, we could connect our dots, giving us the line for the equation. Now, for your assessment or for your problem set, I don't really care which way that you do it. I do ask that you at least understand how to do both ways, but I will never say that you have to do one way or the other. As always, let me know if you got questions. We are more than capable of talking about them when I'm back.